To solve another Leetcode problem, 2436, minimum split into subarrays with GCD greater than 1. So what is GCD? So for the GCD, it can calculate some numbers. So for example, we can calculate GCD with 12 and 6, it's gonna be 6. And also with 3, so it's gonna be 3, because all those numbers divided by 3, it's gonna be integer. Yeah. So let's try to check what is the GCD 12, 6, and 3. As you can see, the result gonna be 3. So the first step is we should understand how to calculate the GCD. Yeah, so for this example, as you can see, the output is 3. Yeah. So how can we calculate the GCD? We can directly use the GCD in Python. So for example, if we were to calculate 3 consecutive numbers, we can just put it inside. Yeah. But also we can, I think we can use the ON time to calculate the GCD, n log n time for this time complexity. Even this n is 2000, I think it's okay. So yeah, but what if we were to calculate 3 numbers? We can calculate the first 2 numbers, so it's gonna be 6, and then we're gonna use the 6 and 3, the GCD of 6 and 3, so the result gonna be 3. So we're gonna calculate the GCD in this way. Yeah. Now let's just write the function. So n should be the length of the nums, because we are going to calculate the minimum number of subarrays that can be obtained after the split. So we can split it like this. This is one split. Another split is 14 and 8. Yeah, because 3 and 14, the GCD would be 1. It is not possible. So we have to split it like this, the first one and the second one. So we're going to return a 2. Yeah. Now, we're going to prepare a result as 0. So for I in range 1 to n. So we're going to start from the second number, because we are going to calculate the GCD. Yeah. So the GCD of nums I minus 1 with our current number nums I. So for this example, the GCD of 12 and 6 is gonna be 6. Yeah. So we're gonna record this number at the nums I position. After GCD, we're gonna update this 12 and 6 to 6, and after that 6 to 3 to update the nums I to 3. So we're gonna update it like this. Yeah, because for the next number we're gonna use it. So the nums I. So this is similar like the dynamic programming. We just put it in place. So nums I would be equal to the GCD with nums I minus 1 and the nums I. Yeah, because after the next step, we will not calculate the I minus 2. We only calculate the one number before it. So for example, while calculating 6, we're gonna use 12. So while calculating this 3, we're gonna only use this 6. So this 6 is the GCD of 12 and 6. Yeah. So this is for the next number. Yeah, but we need to check the GCD values first, if it is more than 1 or not. Yeah. So if the result of GCD is more than 1, so we're gonna update it like this. Yeah. So if it's more than 1, we will update it every time. So the GCD, the nums I, will become smaller and smaller. But what if the GCD equals to 1? So else. So the else means if this GCD equals to 1, so our result should be updated to 1. But this may cause some problem. Yeah, if we directly return the result, it's gonna cause some problem. So for example, we only have 12, 6, and 3. What's gonna happen? Yeah, as 12 and 6 and 3 can become a group. Yeah. So for example, for this 12, 6, it's gonna be updated to 6 nums I, and GCD gonna be 6. And for the next one, 6 and 3, the GCD would be 3. So the nums I would be updated to 3. But our result is 0. That is not possible. but actually our result should be 1. So what gonna happen for this kind of a case? So this means we need to put a prime number inside of the nums, and this prime number would be a very big prime number. Normally it should be bigger than 10 to the power of 9. Yeah, because if we find a bigger prime number with a number inside 10 to the power of 9, basically the GCD of them gonna be 1. Yeah. So if I just run it, as you can see, it will be wrong. As you can see, the output is 1, but actually it should be 2 for the first example. Yeah, that is also makes sense. So this is why we're gonna append a big number. I think it's gonna be 10 to the power of 9 plus 7. So this is gonna be a very big number. So this number is a prime number. So this means for this testing case, definitely it's gonna be 1, because up to here it is okay, but after that 3 with this number. So the GCD of them gonna be 1, and we're gonna record a result plus 1. So after that we're gonna return the result. And similarly for other examples, if we have if we have this example 1, yeah, so from here it is okay, so the result is still 0, but from 3 to 14 the result will be 1. So 14 to 8 the result still be 1, but we needed to have this number. After we have this number, so this means basically we're gonna record another one for the result. It's gonna be 2. So this is easier to check the edge cases, otherwise you have to check a lot. Now let me run it to check. As you can see, it works. Now let me submit it to check. Yeah, as you can see, it works and it's pretty fast. And the time complexity here is O(n). N is the length of the array, and here is a GCD. So the GCD is log m. So m is 10 to the power of 9. So the time complexity is n times log m. M is 10 to the power of 9. It can be a really big number, but log m would be a smaller number. So this is why it is so fast. Thank you for watching. See you next time.